The 4 questions on the back page are exactly the same, or almost exactly the same, except I start to change up the information that's given. So I'm going to take a physics approach. Most physics teachers will try to get you to write every single number that's available and then put a question mark next to the number that you're looking for. Okay? And I'm also going to follow the basic formula that I gave you. It's unconventional, but whatever. Okay? Final amount equals some initial amount multiplied by a growth or decay rate to the power of time. Of course, it changes a little bit if we're dealing with half-life, but right now, typically, the half-life is just 1. There's no fraction there. Okay, so here we go. I actually don't have a copy of this. Okay, here it is. In investment, so number 6 is where we're going to start. If you want to put a little disclaimer on top of each question, along with me, then go ahead. This type of question is solve for the final amount. Okay. An investment was made at $15,000. So you know that's how I start with. That's what I started with. The rate is given as 6.4%, but of course we can't use that. We need to turn it into a number.
0.64.
0.64. We have this money sitting in a bank account for 6 years, but as a little bonus, I'm going to always remind you, these two must match in time period. If it does not match in time period, something is not right. You're going to get the wrong answer. The question is, how much did the investment grow into? So when you do it this way, it seems a little bit easier to piece together. You don't have to do it this way, but I like it because it organizes my thoughts. Let's put it all together. The final amount is what I'm looking for. I start with 15,000. I am increasing, because it's interest, by 0.064 15 times. Every year, 6.4, and I do it for 15 years, so I multiply 15 times. Someone's going to have to do that for me, and I can move on to the next question.
38,000. 37.
And 37.0.8 something.
825.
825, so about 83 cents. Good? Not bad. It's not exactly 7%, okay? But make a decent amount of money in 15 years. Decent. Okay. Depends on what you're comparing to. Part B, don't think too hard. It's just an extra bonus. How much interest was accumulated? It's just a logic piece. If this is how much I had, and this is how much I have now, how much of that is not your money? Or wasn't your money but you earned as interest? And just subtract. Okay, so I'll just do that very quickly. That much was earned as interest. Okay. Moving on. Instead of going into question 7 or 8, I'm going to jump to question 9 because I think that's the next slightly harder. Number 7 and 8 jumps the gun a little bit. Okay. Number 9. This type of question is when you're solving for the initial amount. And you'll see. Number 9, an investment grew to a value of 150,000. They give you the time already. 20 years passed. If the annual interest rate was 6.4%, so I'm going to write it as a decimal. Please note that it is matching. Okay, I give you in years, and the percentage is in years. What is the initial value?
What letter represents the initial value? Is it,
I wrote AI. When we actually get into the financial math, I'm going to change that into a bank term called the principal. Right? So if you do any kind of loan lending or borrowing from the bank, you will see the word principal thrown out everywhere. Okay? So just know, initial amount, final amount is what we're going to do for now. You'll see that change later on. The final amount is 150. The initial amount, I do not know. It is going to be growing. 100% gets added by another 6.4% for 20 years. And when someone does that for me, at least someone can calculate this portion for me. 1 plus 0.064, and all of that to the power of 20. Should be at 3 point something according to what I have. Everyone got it? Yep.
3.45806.
Okay. And the final, the initial amount then, if I want to get that all alone, I have to divide both sides by that particular number. We have 150,000 divided by 3.45806, which means the initial amount was equal to silence. Even if you're not sort of participating in and putting your hand up, at least go through the motions of punching it in because it'll be good practice.
It's 4.337.
I think you forgot a decimal.
No.
Dash?
And 43,306 and 76.
Sorry, 43,376
and
92. There it is. That's how much I started with. That's how much I ended with if I had that rate for 20 years on average.
so
Okay.
it's at 0.92 now. Yeah.
92.
Wait, is that a 0 or a 6? 4, 5,
4.
This?
Oh, it's 6.
0, 6.
No, the other one, yeah.
Okay. Number 7. This is a question. No, that's number 8. Number 8. This is when solve for R. When you don't know the rate. And notice how the numbers will you still list it the same way, but when you plug it in, there's something else that you have to do. You know what I'm saying? We have an investment that started with 15,000. It grew to 150,000. The time that passed was 20 years. What was the rate per year? Someone just draw that? Let's do my great terms. You realize 85%. Okay, so final amount is equal to initial amount multiplied by some rate that is multiplied 20 times. How do I get that all alone? 2 people? Someone else want to?
You have to divide both by 15,000.
Perfect. I'm going to divide both by 15,000. I get 10 is equal to that. And so here comes the exponent laws. I want to get rid of a power of 20. There are 2 ways we can reverse the process and figure out the to get rid of an exponent of 20. The 20th root, or you could translate that and say 1 over 20 as the exponent, right? So just because Elizabeth suggested, let us do the 20th root on both sides, and I don't expect anyone to put that in their heads. Take out a calculator. What you should be left with is an exponent of 1, which is, I'm not going to write, and 20th root of 10. Something multiplies itself 20 times. Yeah, continue on. It becomes
1.1220
Okay, 1.1220. And to get r all alone, subtract both sides by 1. I think you can do that in your head, right? R is equal to 0.122. So what is the rate?
12.2%.
That's a decent interest rate. That actually happened. Multiply your money tenfold in 20 years. That's crazy. Just from letting it sit there. And lastly, we have space. Okay. I'm gonna have to edit. Okay. Last bit. I'll do number 9 here just so it can be preserved for future viewing if you need it for over the weekend. Number 8.
Wait, numbers.
Number 9.
Number
9.
7. Solve for t. In other words, guess check for the exponent. Right? So if the exponent is unknown right now at our level, unless someone else taught you this thing called logarithms, you can't solve it by regular algebraic methods. You have to guess and check, unfortunately. Okay? Pardon?
Why are you doing 9?
Number 9, we did it earlier. Okay? Okay. You with me? An investment of $15,000 in the beginning. The rate is still 0.064. If the investment grew to $150,000, how many years would have had to pass? I'm going to set it up.
Do you have to rate that
Nope.
on the test? No.
It would be nice to, though. I mean, it's really a good habit if you are going into some of the more applied sciences. Okay? So, make our life simple. I'm going to divide both sides by 10, just like the previous example. Oh, sorry. Divide both sides by 15,000, just like the previous example. And from here, we do not know, right? Without logs, must guess check. So, I'm going to go off on a whim. Let's see. E.g., can you do 1.064 to the power of 10? Navarro, can you do to the power of 20? Magnolia, can you do actually to the power of 30? And I'm not sure. I think I just have to go further.
1.85.
Oh, just give me a second. And Jess, could you do to the power of 40? I'm not sure if I have to go any further than that.
1.85. 95.
Okay, that's enough. There. Okay. The 20. 3.458. Still not enough. Oh, now you know what you're doing. Did you find it?
Yeah, I think.
Okay.
6.8421.
I'm gonna guess it's correct. No, maybe I should thought. My calculator's
No,
not.
it's not. It's like probably 87 or 8.
What? Anyways, power of 40? Yes?
11.95.
Okay, so obviously we've gone past that point, right? We've gone past 10, but we're not yet at 10.
Oh, okay.
So it has to be somewhere
35.
in between. You know what? Let's try it. So 1.064 to the power of 35.
No,
I think it's 37.
37. So
no,
we'll
it's
get.
38.
Let's try it. Let's try it. 35, and then we'll start getting closer and closer to it. 8.76. Not enough. So someone is suggesting 37.
38.
Or some say, okay, so 37 is?
It's 9.927.
Woo, pretty close. And someone might feel inclined to try 38.
9.56.
10.56. Okay, so in terms of differences, this is definitely closer. So I would go so far as to say, unless you're really keen on getting the exact number and trying like 37.5 or something, you would say, because this is a guessing check, I will accept it. It takes just over 37 years. Get what I'm saying? If it's 5%, it's more than 37, but it's definitely not 38. Communicating that is enough. Okay? And maybe if you venture into grade 12, you will learn a lot. And it'll be a lot easier just because you understand the concept better. Okay? So take a look. So these are the 4 types of questions that we've done together. You will see some half-life stuff, so the fraction may appear in your exponent, just because, you know, it's a time period. You have to adjust based on that. But otherwise, this is it. The only thing you might have to worry about afterwards is, exponent laws.